Good afternoon, students. Myself, Anuradha Haith from Statistics Department from Thakur College of Science and Commerce. Today, I'm going to teach you the topic probability of statistics, right? So, what is the meaning of the word probability? Probability means possibility or chances. Okay, so let me write down what is probability. Probability means possibility or chances. So let us take an example. Suppose I tell you that today is Wednesday, tomorrow what will be the day? So there is no question of chance. Obviously tomorrow will be Thursday. How many days are in a week? There are 7 days in a week. No question of possibility or chances. But if I ask you that tomorrow whether there will be rain or not, so there are two cases. There can be rain, there cannot be rain. So the question comes, what is the chance of raining tomorrow? What is the chance of not raining tomorrow? The question of probability comes here. Suppose there is a cricket match between two countries, India and Australia. So what are the possibilities? India can win, India can lose, the match can be cancelled, there can be a draw. So there are four possibilities. So the meaning of the word probability, possibility or chance where we are not sure about it. Any experiment where we are not sure about the answers, there are many chances. The experiment is called random experiment. So first point, we should know what is the meaning of this word random experiment. So what is random experiment? As I told that when we are not sure about the answer, there are chances of different occurrences. In another example, we will say that suppose you throw a dice. So what are the possibilities? The dice, if you throw, we get 1, 2, 3, 4, 5, 6, right? If you throw a coin, what are the possibilities? We get head and tail. There is a cricket match. The possibilities are winning India, yeah, losing, yeah, there is a draw, or the match is cancelled. So this is the meaning of this experiment is called random experiment where there can be more than one possibilities. Now before coming to the exact definition of this probability, first we have learned what is random experiment. Second, we are going to learn what is the meaning of sample space. The second definition is sample space. We will denote it by capital S. Now what is sample space? Just now the example we have taken, if we throw a dice, how many points are there? 6 points. So collection of all possible observations under the experiment is called sample space. We denote it by S. We write in this way: 1, 2, 3, 4, 5, 6, right? Similarly, if you throw a dice, this is the answer what we got. Similarly, if I throw a coin, what we will get? Head and tail, right? If I throw two coins, so what are the sample space? We may get head head, we may get like head and tail, we may get tail head, yeah, tail tail. Okay. Next, the definition comes event. The third definition is event. Now what is the meaning of event? It is a subset of the sample space. Suppose this is the sample space S. Any subset we define, denoted by capital letters A, B, C, are called event. So event is a subset of the sample space. For example, the same example if I take S equal to, write 1, 2, 3, 4, 5, 6. This is the sample space of throwing a dice. Now if I say, let us define an event of odd numbers. So what I get here? 1, 3, 5. This is an event. Suppose I say that multiple of 3. So what I will get here? 3 and 6. So event is a subset of the sample space. So we have learned the definition of random experiment. First, second is the sample space, and third is the event. Number 4. We are going to learn the fourth definition, which is called mutually exclusive events. I'll just take an example here. Suppose you throw a coin. So you may get either head or tail. Obviously, if you get head, you will not get tail. If you get tail, you will not get head. Two events are called mutually exclusive when occurrence of one event restricts the occurrence of the other. If you get head, tail will not come. If you get tail, head will not come. Similarly, if you throw a dice, even number comes, so odd number will not come. If odd number comes, even number will not come. So if I define two events A and B, when they will be mutually exclusive? When there is no common point between them. So I will write A intersection B equal to 5. 5 is the null event, right, or the empty set. So Two events are called mutually exclusive when A intersection B equal to 5. Next definition, we will come to exhaustive events. What are these? Exhaustive events. So let us take the same example. Throw a dice. A is 1, 3, 5. Okay, fine. 1, 3, 5. What we have defined B equal to multiple of 3, that is 3 and 6. Now I define a new event here, C, which is even number. So 2, 4 and 6. Now what we are going to do, instead of intersection, we are going to take union, right? If I take A union B, union means you are taking all the points together. So if I take A union B, what are the points I get? 1, 3, 5 and 6, right? If I take the intersection of A and C, like A union C, what I am getting here? 1, 2, 3, 4, 5, 6. All the points I am getting, which is nothing but the sample space, right? A and C are called the exhaustive events here. So what is the meaning of exhaustive events? If I take two events or more than two events, take the union and get back the sample space, it is called the exhaustive. The events are called the exhaustive events. Next, we are coming to the definition of equally likely. Okay, equally likely means that if you throw a dice, you can, any point can come. It can be 1, 2, 3, 4, 5, 6, anyone. So every point has equal chance of coming. So when any outcome of the random experiment has equal chance of coming, they are called equally likely. So if you throw a dice 1, 2, 3, 4, 5, 6, all the points will be equally likely. So we have done the definition of the meaning of the word probability. Then what is the meaning of sample space? Event, right? Then mutually exclusive event, exhaustive event and equally likely event. Now we are coming to the mathematical definition of probability. Meaning of the word probability we have done. Now this is the mathematical definition of probability. The mathematical definition of probability is that if a random experiment has n outcomes, okay, and the outcomes are all exhaustive, equally likely and mutually exclusive, then out of them, out of all these n outcomes, if m are favorable to the event A, m are favorable to the event A, okay, then probability of A is defined by m upon n. So this is the mathematical definition of probability. Probability of A will be m by n. For example, if you throw a dice, S equal to 1, 2, 3, 4, 5, 6. So how many points are there? 6 points. N equal to 6. Now I'm interested to find out the probability of A here. What is A? We have already defined. A is that the odd number. So how many odd numbers are there? 3 odd numbers are there. So write the formula m by n. M is equals to 3, n equal to 6. So my answer will be half. So this way we find the probability. Okay. Now we are coming to some problems of probability. So this is the mathematical definition of probability. Using the formula, we are going to find out some probability. So look at the first problem. Already the problem is here. Two unbiased coins. Unbiased means probability of head and probability of tail will be equal. Okay, the total, one more thing you should know here before coming to the problem, that the total probability is always equals to 1. Okay, and each and every value of probability will be lying between 0 to 1. It will never be more than 1, not less than 0, and the total probability is 1. So two unbiased coins are tossed simultaneously. Find the probability of getting exactly one head, at least one tail, majority of heads, right? So if you are tossing two coins, okay, so what you are getting here? You are getting here sample space equal to what? Head, 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 tail, tail, head and tail, tail. So how many outcomes are there? 4 outcomes are there. So I will write here n equal to 4, as there are 4 outcomes in the random experiment. Now first question, probability of exactly one head. So we will write the formula first, that is m by n, exactly one head. Now look at this sample space, exactly one head. How many cases you are getting? You are getting 2 cases here, that is head tail and tail head. Okay, in these 2 cases we are getting exactly one head. So how many cases are there? 2 cases. So my answer will be 2 by 4. Okay, so that is half. That is the first answer. Now come to the second question. What is the second question? Probability at least one tell. The meaning of the word at least is minimum. So at least one tell means it will be one tell or more than one tell. So come to the sample space. What we are getting here, more than at least one tell we are getting here. Head tell में we are getting one tell, this case. Then tell head में we are getting one more tell, right? One tell only, and tell में we are getting more than one tell. So total how many cases are there? At least one tell. There are 3 cases. So my answer will be 3 by 4. Majority of heads. Majority of heads means actually the meaning is more number of heads than tails. More number of heads than tail. First case, it satisfies this condition because there are 2 heads, no tail. So majority heads you are getting here. Here exactly 1 head, 1 tail. So there is no majority of head. Second case, third case, fourth case, it is not satisfying the condition. What is the condition? Majority of heads. So how many things are satisfying here? How many outcomes are satisfying? Only one, the first one. So my answer will be, the third case will be majority of heads. The answer is 1 by 4. Okay, so the first answer is half, second answer 3 by 4, and the third answer is 1 by 4. Now the second problem. The second problem, a box contains 20 tickets numbered from 1 to 20, right? So let me write the sample space first. Sample space will be, there are 20 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So what is the value of n? N equal to 20, as there are 20 numbers. Now one ticket is drawn randomly from the box. Find the probability that the number on the ticket is divisible by 5, etc., etc. So let us do one by one. First, patch. Patch. First one. Probability divisible by 5. Now look at these numbers. Okay, out of these numbers, how many numbers are divisible by 5? It's just a 5, table of 5. That is first here, this number 5, then 10, then 15 and 20. So how many numbers you are getting? 1, 2, 3, 4. So my answer is 4 by 2. You can simplify. 1 by 5 is the first answer. Second, not divisible by 2. So which are the numbers which are not divisible by 2 here? All the odd numbers like 1, 3, 5, etc., etc. So out of 20, how many odd numbers are there? There are 10 odd numbers. So second answer will be 10 by 20. So this is half. Okay. Now come to the third one. The third question is divisible by 3 and 4. So let me write which are the numbers divisible by 3. Then I will write divisible by 4. So divisible by 3 by 3. Okay. So 3, 6, 9, 12, 15 and 18. Right? These are the numbers divisible by 3 between 1 to 20. Now which are the numbers divisible by 4? So let us write here divisible by 4. So what are the numbers? 4, 8, 12, 16 and 20. 4 ones are 4, 8, 12, 16 and 20. So the third question, let me just check the third question. What is it? Third and fourth both will do together. Divisible by 3 and 4 both. And the fourth is divisible by 3 or 4. So which are the numbers? Are you getting any common numbers which is divisible by 3 and 4? Yes, there is a number. What is that? 12. Okay. So my third question answer will be 1 by 20. Okay. And the fourth question. Okay. Fourth question is 3 or 4. The numbers which are divisible by 3 or 4. Right. So here we are getting how many numbers? 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5. Total 6 plus 5, 11 numbers are there. But I can see a common number. So that common number we have to cancel. So 11 minus 1. So it will be 10 by 20. The answer is half. We are getting the answer as half. Okay. So this is the second problem. Now we are coming to the third sum. One unbiased dice is thrown. Find the probability that it shows number 5 and it shows odd number. These two questions are there. It shows the number 5 and it shows the odd number. Okay. So if I throw a dice, we have already seen that the numbers are 1, 2, 3, 4, 5, 6. So how many numbers are there? There are 6 numbers. Now the first question, that the number is 5. So a key number, only one number is 5. So what will be my answer? It is 1 by 6. Now come to the second question. It shows odd number. That also we have already done. Second question, odd number. How many odd numbers are there? There are 3 odd numbers. So my answer is 3 by 6, which is equals to half. Okay. Now fourth problem. Two unbiased dice are thrown. Find the probability that both the dice show same number. First dice shows 6 and the total of the numbers on the dice is 8. So when you are throwing two dice, okay, so every dice the number 1 to 6. So two dice over, if there are two dice, then the numbers will be 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Then 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. So this way we have to write all the numbers: 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Then 4 1, 4 2. We have to continue till 6 6. 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So total how many numbers are there? There are 36 numbers. So n will take the value 36 here, because 36 points are there in the sample space S when you are throwing two dice. Now the first question is, both the dice show same number. Both the dice show same number. So which are the numbers same here? Like 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. These are same numbers in both the dice. So how many cases are there? 6 cases. So first question answer will be 6 by 36, which is 1 by 6. Second question. Second question, what is it? Second question is, first dice shows 6. So first dice, the first number is the first dice number and the second number shows the second dice number. So last column, if I see that the first dice shows 6 number, how many cases are there? Again there are 6 numbers. So what is the answer? It will be again 6 by 36, which is 1 by 6. The third case is the total of the numbers on the dice is 8. If you add the two numbers, you should get 8. So from where we are getting here? We are getting from 2 6, 2 plus 6 8, 3 plus 5 8, 4 plus 4, 5 plus 3 and 6 plus 2. So how many cases are there? 1 2 3 4 5. There are 5 cases where you are getting the total number of the two dice equal to 8. So what I am going to write here, the third answer will be 5 by 36. You can keep it as the fraction or you can find the decimal also, right? Now next problem, number 5. A bag contains 10 white and 11 black balls. If two balls are drawn simultaneously from the bag, find the probability of getting both white balls, one white and one black ball, no white ball. Now before starting this problem, little bit of concept of permutation and combination, at least the concept of the combination we will discuss first. Then we are coming to this problem. Combination. The meaning of the word combination is selection. Okay. If there are, suppose there are 3 objects A, B and C and we have to select 2 out of them. So what we can do? AB, AC, BC. We will write 3C2 and the formula will be 3 factorial upon 2 factorial, 3 minus 2 factorial. So let us check. 3 factorial is 6, 2 factorial is 2 and 3 minus 2, 1 factorial is 1. So I get the answer 3. Here also I get 3 cases. Okay. So combination means selection, and what will be the formula? In general, if there are n things and r to be selected out of them, we will write in this way, NCR, and the formula will be n factorial, r factorial, n minus r factorial. Okay. Now let us come back to the problem. A bag contains 10 white and 11 black balls. 2 balls we are drawing simultaneously from the bag. Okay, find the probability of something the question is given. Now total how many balls are there? 10 plus 11, 21 balls are there, and we are selecting 2 balls. So what we are getting here, we are getting here n equal to, from 21 we are selecting 2, so 21 C2. So we will do it 21 factorial, 2 factorial into 21 minus 2, which is 19 factorial. So what I'll get here, 21 into 20 into 19 factorial, then 2 factorial is 2, and then 19 factorial get cancelled. So 21 into 20 by 2, I will get the answer 210. So I'm getting n equals to 210. We can keep it 21 C2 also. So 21 C2, if I split it, I will get the answer 210. Now the first question is that, let me go back to the question what is given here. The first question is that both will be white ball. Second question, one white and one black, then no white ball. So let us come to the first question, both white ball. Okay, first question, probability, that is both are white ball. So total how many white balls are there? So in the bag there are 10 white and 11 black balls. So from 10 you have to select 2, right? Because both the balls are white. So what I will get here, 10 C2 divided by 210 will be my answer. Now we have to split this 10 C2 and get the answer also. So 10 C2 we have to find out, like 10 C2, that is 10 factorial, 2 factorial and 8 factorial. So 10 into 9 into 8 factorial, 2 is 2 and 8 factorial get cancelled. So what I will get here, 45, and my answer will be, the first answer will be both are white ball, that is 45 divided by 210. We can simplify and get the answer. Second question, one white and one black, right? Now in probability, AND means we have to multiply, OR means we have to add. AND means the intersection and OR means union. So we have to select one white ball and one black ball, and the total number of case is 210. So anything combination 1, if I split it, right? So it will be the value itself. So 10 C1 will take the value 10 only, 11 C1 will take the value 11. So my answer will be 10 into 11 divided by 210. We can simplify and get the answer. And the third is no white ball. No white ball. So no white ball means all the balls are black. Both the balls we are selecting. No white ball means both will be black. So how many black balls are there? 11 black balls are there. From 11 we are selecting 2. 11 C2 divided by 210 will be my answer. So if I can simplify 11 C2, okay, let us do that. 11 C2, it is 11 factorial, 2 factorial into 9 factorial. So what I will get here, 11 into 10 into 9 factorial, 2 factorial is 2 and 9 factorial, it gets cancelled. Then I am getting the answer, it is equal to 55. So my answer will be here 55 divided by 210. Okay, so this is the case of probability of no white ball. Next problem. A card is selected at random from a pack of cards. What is the probability that it is a picture card, S card, spade card, black queen card? So before coming to the problem of this card problem, let me explain what are the different type of cards. In a playing cards, there are total how many cards are there? There are 52. Okay, and how many types are there? There are 4 types, like spade, club, heart and diamond. Each type, how many are cards are there? 13 spade, 13 club, 13 heart and 13 diamond cards. Spade cards is black color, club is of black color, this is heart is of red and this is also red. So total in a pack of cards there are 13 spade cards, 13 club cards and etc. Total there are 26 black cards, there are 26 red cards. Okay. Also that every type, any type if I take, suppose this is the spade card, 13 cards I'm taking. So let us do what are the different type of spade cards in that 13 lot of 13. The first card is A, we'll call it S card. Okay, right? And then the number card starts 2, 3, 4, 5, 6, 7, 8, 9, 10. Next is Jack, Queen and King. So these are the total bifurcation of the cards, right? So what I will get here? Total how many S cards are there? Total there are 4 S cards. Okay. How many Jack cards are there? 4. How many Queen cards are there? 4. How many King cards are there? There are 4 King cards. So each type, like S cards, there are 4 S cards, 4 Jack cards, 4 Queen and 4 King, and these are the rest of the unnumbered cards. Now this Jack, Queen and King, these cards, Jack, Queen and King, these cards are also called picture cards, okay, or it is also called face cards. So total how many picture cards or face cards are there in one type? Just a minute. I'll solve it here. This problem later on we will do it. So total how many picture card or face cards are there? Total 12 face cards or picture cards in each type, like 12 face cards of spade, 12 face cards of club, etc, etc. This way we count what are the different type of cards. Now coming to the first problem, let us come to the first problem. Let me copy here. Okay, a card is selected at random from a pack of cards. What is the probability that it is a picture card, S card, spade card, black queen card? So n equal to total number of cases. Total number of cases. So how many cards are there? 52. From 52 we are selecting 1. So anything combination is the value itself. So 52C1 is equals to 52. Now the first question is that what is the probability that it is a picture card? So probability of picture card. Okay, total how many picture cards are there? Each type there are 3. There are 4 different types, right? So 3 4s are 12. So 12 divided by 52. Okay, so you can simplify 12 divided by 52 in decimal, or you can just write the answer 12 by 52 also. So if I simplify, I get the answer 12 divided by 52 is equals to 0.23. So this is the first answer. Second, what I get here, it is a ace card. So total how many S cards are there in the pack of cards? There are 4. So it is 4 by 52. Actually it is 4C1 divided by 52C1, which is nothing but 4 by 52, and the answer comes as 4 divided by 52 is equals to 0.08. This is the second answer. Now the third one, that it is a spade card. Okay, so how many spade cards are there? There are 13 spade cards, so it is 13 by 52, that will be 1 by 4. So the answer is 13 divided by 52, you will get 0.25. Okay, now the fourth question is black queen card. Interesting, black queen card. So let me write first black queen card. So total how many queen cards are there? Total there are S, club, heart and diamond. So there is a queen, there is a queen, every type there is a queen, but this queen is black color, this queen is black color, this is red color, this is red color. So total in a pack of cards, how many black queens are there? Only 2. So my answer is 2 by 52. So I get the answer as 2 divided by 52 is equals to 0.04. Okay, next question. Instead of 1 card, if I select 2 cards, what happens? So let me copy this question. Next question. 2 cards are drawn at random from a pack of well shuffled cards. Find the probability that they are a king and a queen, both are ace, 1 black and 1 red, 1 spade and 1 club, both are heart cards, one of them is an S card. Fine. So this problem, n equal to how many cards are there? 52. From 52 we are selecting how many? 2, right? 2 cards are selected, so 52 C2. I get here 52 factorial, 2 factorial into 50 factorial. So what I get here? 51 into 50 divided by 2. Okay, so because 52 factorial is 52 into 51 into like I made a mistake here, this will be 52 into 51. So what is the value? 52 into 51 divided by 2. So it is 1326. right? Now first question, both are S's. We can keep the rest of the answers, that is the combination part, you can do it afterwards. We'll keep the answer in like 4C2, 5C2, whatever we will get, in that way only. So first question is probability of both will be S. Both are S cards. Fine. In a pack of cards, how many S cards are there? Just now we have done, there are 4 S cards. So 4C2 divided by 1326. You can simplify this 4C2 using the combination formula and get the answer in fraction or decimal. Second question, what we are getting here? 1 black and 1 red. Fine. 1 black and 1 red. I'm getting 1 black card and 1 red. Okay. In probability, and means if they are independent. Later on we will do the laws of probability, and obviously black card and red card, they are independent. Then we multiply, and or to we add. So 1 black card and 1 red card. How many black cards are there? There are 26. From that we are selecting one. For and we are getting multiplication, and 26 red cards we are selecting 1 divided by 1326. So 26C1 is 26, 26C1 is 26 divided by 1326. We can simplify and get the answer in fraction, yeah, decimal. Next the question is 1 spade and 1 club. Okay, 1 spade and 1 club. So how many spade cards are there? Number 3, 1 spade and 1 club. So how many spade cards are there? There are 13. From 13 we select 1, and multiplication. From 13 we select 1 divided by 1326. So we get the answer 13 into 13 divided by 1326. This is the probability of 1 spade and 1 club. The next question is, what I get here? Both are heart cards. Next is one of them is an S card. Okay, so how many heart cards are there? Each type we have done, there are 13. We have seen that there are 13 cards. So both are right. So from 13 we are selecting 2 divided by 1326. Again you have to simplify and get the answer. Number 5. This is interesting. One of them is an S card. One of them is an S card. Fine. So total in a pack of cards, how many cards are there? 52. How many S cards are there? 4. So how many cards are not S? 52 minus 4, that is 48. 4 S cards are there, these are not S. Now the question is, one of them is an S card. We are selecting 2 cards. So if one is S card, what will be the other one? The other one will be not S cards. So from this we are going to select 1. From this we are going to select 1. So basically we can write 1 S and 1 not S. Okay. So 4C1 multiplied by 48C1 divided by 1326 will be my answer. So 4C1, which is equal to 4, 48C1 is 48 divided by 1326 is the answer of the question. Probability one of them is an S card. So these are the sums we have done for mathematical using the formula mathematical definition of probability. Now we are coming to the next part of the probability, which is called laws of probability. So next we are going to start laws of probability.